Good afternoon, everyone. I have the pleasure of heading this very nice team of Norwegian companies and research groups. And we are 13 now. We're trying to become 25-ish in the next application going in November. And actually, my home, which is this building here, is at IFE Kjeller. It's 20 kilometers east, but I'm also a professor at the physics department, so I belong to both worlds, if you wish. And this is just a small fraction of a fairly large amount of tens of different Norwegian companies involved in this segment. The global picture is much more interesting, of course. What I want to talk about today, I think I was invited to say something about the big picture. I mean, is solar actually becoming anything big? So I'll spend a lot of time on that, but I can't resist discussing actually the main interest of mine is which actually what can Norway do? What can we do as researchers, as companies? Is there something for us to do? And I would say there's a huge amount of opportunities here. The first question first, I mean, if you look at what's happening, of course, a lot of skeptics in the many audiences, and this is 2000. This is the European power production capacity in 2000, and PV, photovoltaics, this is the solar cell part. It's a very nice and round figure. It's nothing. And quite a lot of people, of course, will have had their education in energy before this time, obviously. If you then move a tiny bit ahead into, say, 2013, this is then the numbers a couple of years back, and you see that solar has gone up to close to 10% of the power capacity. Wind, of course, from also a tiny number here, has grown even further, so we see that things are happening. And if you actually look at what's new every year, we see that this is all new energy coming online in Europe per year in the electricity segment. And of course, wind and solar dominate for the last couple of years. So in terms of investments and in terms of new capacity, those two are the most interesting things happening right now. And gas also doing well, so I mean, it's basically a third on each, but I mean, there's a lot of renewable capacity coming online. So that's one part. So it's already happening to some extent. So this is just one snapshot. This is 2013 again. So I mean PV, and this is again this would be 10 gigawatts of power. We're going to get back that number soon, which is I don't know 10, 15 terawatt hours, but 2013 numbers in Europe. But already something. If you look at the investment part, so this again everything that's all been built before is of course in place still, but we now see that all the changes are extremely in favor of renewable technologies. This shows the solar graph by itself. So this is the annual installations. This is not an accumulated graph, so every year is like new capacity. And I started doing solar cells here, and of course nothing happened, and just because of me, no, obviously because of first the Japanese, then the Germans, and then the Chinese, we have seen a tremendous growth. It's exponential more or less. It's not anything like stable. But the recent numbers, if you look at 2014, you have close to 40 gigawatts of capacity. We don't know exactly where we're going to end up this year, probably 50-something. China is overshooting their mark again. Many cool things with this. I mean, first of all, we see that several markets are in play. The scary thing here was that in 2004, almost all panels were built in Germany, and that's not stability. Now we have many global markets coming online, and even Japan, they are mostly building all their plants, although some of their stability issues are still going on. Most of what's planned is built. And we could spend a lot of time discussing stability because it's also a very standard tool for the utilities to fight renewables. But of course, we need stability. We have limits to push against. The other cool thing is, of course, if you do 40 gigawatts in a not too sunny place, but still quite decent, we're doing like 50 terawatt hours. So the solar cells installed last year alone could power more than Denmark. And Denmark is a tiny country, but still one full country. So there's quite a lot of things happening. This year we will do more, so probably close to 50, and probably then with a turnover of approximately 1,000 billion Norwegian kroners. It is smaller than the oil sector, obviously, but 1,000 billion kroners is still 1,000 billion kroners. It's a fairly decent market to take a part of. Still, with that, of course, we are now, in 2014, the world became 1% solar powered in terms of kilowatt hours. And 1% is really cool. Before last year, we were like 0% solar powered. Now it's 1%. But the interesting part again is 9 out of 10 panels ever installed from people made solar cells in the 1880s in Jules Verne's time. 9 out of 10 panels have been installed since 2009. So almost everything is new. And that means that, of course, we just reached 1% last year, but that was 0.1% 6 years back. And that means that 2% is happening really, really fast. Probably now, based on new graphs, in maybe already 2016, at least 17. And that means 5 is going with more growth, and then 10 is also coming quite soon. So this is going tremendously fast. The other thing is, of course, that the world is not a very fair place in many aspects, but you have some crazies, or visionaries, or depending on your perspective. Italy, Greece, Germany are all between 7 and 8% solar powered now. And this is kilowatt hours, this is not power. If you look at the production, I mean, this is June, Germany, 2014. This is what they did in 2014. The good thing is, of course, you can see people waking up in the daytime and sleeping at night, so we have variability. We have been able to handle that before, but all the peaks in June were covered by solar cells. So solar energy was, in the peak hours, doing slightly more than 40% in the extreme hours of all electricity produced in Germany. And this is a 7% country. If you now want to do, say, a 20% country, this will be different. We'll get back to that very soon. We could say December is almost the same demand curve, and the solar fraction is, of course, very, very, very tiny. And that is one of the, intermittency is a very big challenge. We have to really find some solutions there as well. But so far, we are doing quite well. And we can grow something more before we had the biggest issues. We could probably invert these peaks, because that's what people have been operating under before. We know that the gas capacity can handle that kind of variation, but we don't want to do more than 100%, because then we have some really big issues to handle. Okay. You could, of course, also then wonder why on earth is this happening? And of course, many fundamentalists would say, look, this is the biggest resource we have, 15,000 more times energy in the sunlight than mankind uses every year, so we just basically need 1 hour. And this is also very nice. This is the fundamentally important reasons to do solar cells, because if you want to think big, this is the biggest thing we can think of. Unless you find cooler stuff on a different star, but that's for the next cutting-edge conference, I guess. But of course, this is the main backdrop. I mean, the solar panel is a cell phone, is any kind of other device. In the 70s, you had some people who really were desperate for solar panels, who were willing to pay huge amounts of money to get solar power coming in. Since 1977, you had more than 99% cost reduction. And the reason is we have been able to build bigger and bigger and bigger and bigger factories. And when the yuppies at Wall Street bought like 10 cell phones per year, the price was insane. But now you sell, I don't know, hundreds of millions of cell phones every year, and the price is completely different. And the same goes here. Now we are going to make 10 or 15 billion solar cells this year. And then the unit price per solar cell is extremely small. And actually, in 2015, we are looking at 0.5 watts, or dollars per watt, so it's not 0.74. So we had some reductions even in the last couple of years. And that means also the most interesting products now have retail prices of electricity of, there's a new record in Nevada at 3.9 cents per kilowatt hour, which is like 30 öre or something, 20-something öre, which is really, really cheap compared to anything. And this basically shows the production cell phone perspective. It's a learning curve. Economists like these because they think they can be used to predict the future. So it gives you the average selling price as a function of volume. And if you in a log-log plot get a straight line, many people in the mathematical sciences know that a lot of things look straight in a log-log plot. But anyway, if you can do this over many orders of magnitude, it tells you something about what you can expect in further cost reductions. And here we're looking at something close to 20% reduction per doubling. But of course, it's not smooth sailing. We had a silicon shortage here where the price actually went up. Now we have had a trade war with China, and the prices dropped even further. So it's not a trivial learning curve. But we expect further quite dramatic cost reductions. And that is cool when we already today will win quite a lot of projects based on price alone without any subsidies. Then, of course, the question is how far on Earth can we go? And this is very hard to answer. We know that yesterday, of course, two weeks back it was all black. This is Germany today. California has pushed it to be a bit further in the summer months. So this will be, let's say, base power, and then you have solar just doing the icing on the cake. Then, of course, if you double Germany's capacity, we will be close to 100% solar-powered in daytime, nothing at night. And then, of course, if you want to save the planet, we have to think bigger. And just to put it into perspective, this year, Germany set a new record. Wind plus solar in 1 hour was 78% of all production of electricity that hour. And that is, again, with 20-something% renewable mix, which is not good enough. So storage, obviously, is extremely important. So this shows, the cool thing, though, by solar and wind is that we will always have intermittency issues. And this shows, again, Germany. If you try to solar and wind power Germany together, if you look at the daily charge, it's a nightmare for any regulator. If you are able to do storage solutions on a weekly basis, it's still not fun. You're looking at a couple of 100% of variation. If you're up to 2 to 4 weeks of handling, things are much, much smoother. And there's quite a lot of calculations and studies seeing if you can, of course, we're still looking at massive scale energy storage, but a couple of weeks seems to be enough for many countries as long as you have the right mix to start with. Of course, in Norway, we would add hydropower, which is the best resource you can have. If you could choose, everyone would have hydropower, but they don't. But it's not, fortunately, it doesn't seem to be the case that we need to store things for 6 or 10 months, but we need to have a decent storage capacity. But there was a question related to what's happening in houses, and of course, the electrical vehicles are coming quite fast. That's a huge possibility, underexploited so far. And also, this is, I mean, many companies do. The Tesla was not by far first on batteries, but they get most visibility because Elon Musk is some sort of a hero to some people. Of course, there's a lot of battery packs coming out also, and this was the most sold product ever when it was launched. So it beat the iPhone in terms of volume on the first weekend, for instance. And this is just a battery for people with a solar panel, so they don't have to sell electricity when it's negatively priced, basically. So it's going really, really fast. How far can we go? I have no idea. The International Energy Agency tends to be very conservative. They missed absolutely all data from them have been wrong always. Especially when it comes to solar. They're quite good on the rest, but they have underestimated solar. We have beaten the 2030 perspectives many years back. But even they will say, well, I don't know, 50%-ish renewable wind and solar by, and hydro as part of that by 2050, as just thinking of a number, basically. Shell Solar has a 60% scenario, but at least we anticipate growth also in the coming years. So hopefully it's going to be many tens of percents. Then the question is, of course, what on earth are we doing in this field? Because we live at the North Pole, obviously. And I mean, what we need to think about, we need to think really big. And some companies do that. Scatec Solar, a beautiful Norwegian company, bigging some of the biggest solar parks we find in Africa. And they are thinking large scale. Sustainability, I'm going to get back to very shortly. This is a Norwegian strength. It should be cheap. It always has to be cheap, or else we'll do something else. It has to become cheaper than it is today. And of course, we have policies right now. We're trying to find this Norge etter oljen, Norway after oil. So we want to be the clean tech nation, but of course, take any country. All countries try to do this. So we need to have our edges here. The cool thing is that all solar cells, almost, are silicon-based, 92, 93%. And silicon is a Norwegian speciality. It's not because silicon is rare. I mean, 1 out of 4 atoms in the crust is a silicon atom, so you can find it anywhere, but it has to be refined using high temperature and lots of energy. I'll skip this just to be clear. So the Norwegian strengths will typically be making silicon materials and making wafers and raw materials that we afterwards can put into solar panels made either in Norway or Germany or Japan and China, what have you. But we want to then help them to use the best possible technology to make the best possible solar module in the end. A couple of examples here. We have Elkem Solar has a fairly nice factory or very nice factory at Fiskå, just outside Kristiansand, making more than 6,000 tons every year of silicon going into the solar industry, using a metallurgical process, something that Norway's been doing for hundreds of years, or not hundreds, but more than 100 years at least. But they have refined it, so now they can make 99.999999% pure silicon in terms of impurities at very low cost. And the cool thing also is that this plant, because it's a very unique and energy lean technology and it's using hydropower, is probably the greenest silicon you can find in the world. And we are going to use several 100,000 tons of silicon in the business this year. So the more green silicon we could sell to the world, the greener the solar industry would be. Another example, Dynatech from Askim. They're building up new reactors, trying to make silicon even more energy friendly from silane. We're working hard now with us, but also with the Research Council Innovation Norway, building the 3rd generation reactor right now, going full scale. or at least very large scale. The final reactor will be slightly bigger, but of course these nice people here are still smaller than the volume. We're making quite a few tons every year in this pilot scale. And it's so far going very well. Yeah, I should turn that animation off. The other part we also do is that we try to make high performance silicon materials. Because solar cell efficiency is limited by the quality of the material. Again, here, lots of Norwegian research, Norwegian Crystals as companies making pullers like that. And what we have done is we developed characterization frameworks where you can actually see the material quality. We have developed software that allows us to tune the fabrication processes to actually make the right type of silicon in the first place. So also here we are able to help Norwegian companies sell. I mean, Norwegian, for instance, is selling their silicon to the absolutely most efficient solar cell producers in the world in the silicon framework. And they are extremely selective in what they want to buy. So quality and energy use and sustainability we seem to know. Yeah. So by that, I think I'll thank you for the attention.
Thank you, Erik. So, panel.
Yeah, so I have a question regarding the price decrease or the exponential price decrease that you were talking about. So it's coming from computer science, and the Moore's law, I guess, is a good comparison. And they always talk about how that will stop sometime in the future, but then new driving forces come to push the price further down. And what are sort of the forces decreasing the price? You mentioned the silicon and improvements within that, but are there others? And how long can you expect for the price to decrease within solar power?
It's a very good question. Actually, there are two kinds of forces, because you can say the external forces are also good. Germany has used a subsidy program from 2000 or so and upwards, still in operation, which has been extremely good, where they started out with a very high premium for solar panels. You got paid extremely well to become a solar producer, but then they have cut the tariffs every single year. So now the subsidies are almost gone. And the producers still need to be able to make systems that you can sell in Germany without subsidies, more or less. So there's been and this has been visible all the time. They've said that we will cut rates every single year by this much. So there's been a force to push the prices down. The other is, of course, looking from technology. We see that silicon is one major part that we can improve a lot. The energy consumption of the best Norwegian technologies is 4, 5, 6 times lower than the best competition. And that matters in terms of cost. Efficiency is the other lever. My good colleague Per Anders will talk about that later. But of course, if you push solar cell efficiencies higher without changing cost too much, we get many more kilowatt hours back for more or less the same cost. So efficiency is a very good driver, which for a scientist is cool because, I mean, bigger, better, faster, more is like our business. So high efficiency is a very nice way to go.
Yeah, I guess my question relates to sort of the business part of the whole thing. But it also relates to the price decreases. We have had Norwegian companies that were big on this and didn't end up that well. Mainly, I guess, at least as far as I could understand, from price decreases that they couldn't follow up on. Chinese producers, very cheap. First question, I guess, is there potential in Norway for this when, I mean, you can see other producers doing just as well or cheaper production? And do we have the right policies to get the kind of business we need to get?
Very good questions. When it comes to whether we can make this into business, we see now that the Norwegian producers here are actually making a buck. The upstream part, energy, is one thing that we actually are, the price in Norway is not too bad for energy compared to, for instance, China or any other place to try to do this. So we have a premium. Obvious stuff like cooling water, which shouldn't matter. We have cooling water, which of course you all know in summer. That comes with a price if you move abroad. The technology we have is also better. So actually the cheapest production we have of silicon tends to be based on processes that we have control over. So most of the Norwegian companies this year, for instance, will be making a good profit. There have been big crashes, REC, of course. They still have nice factories in Singapore and the US, REC Silicon, REC Solar, but they were priced out of the market because the Chinese, of course, came in, entered the market extremely fast, pushed prices down very fast, and there's still a trade war going on with respect to that, but I mean, the European Union imported panels for what, 150, 60 billion kroners in 2012, and probably all were sold with losses. So the question is, I mean, how do you compete with that? But in this part of the value chain, at least now we actually can sell solar cell materials to the producers. And we see that they're tidying up the market because, I mean, nobody can sustain living in a 1,000 billion kroner industry with losses. Everybody needs to start to make a buck. So when the Norwegian industry and the German industry was lost, the Chinese also lost a lot of money along the way. But we see a lot of opportunities.
Great. Thank you, Erik.